Welcome to the video, the latest on ductless heat pump installation practices in cold climates. This content was originally delivered as a webinar in the fall of 2020. This video has been produced by the Northwest Ductless Heat Pump Project, which is a program of the Northwest Energy Efficiency Alliance. NEA, as it is called, is an alliance of over 140 Northwest utilities and energy efficiency organizations working on behalf of more than 13 million energy consumers. NEA operates the Northwest Ductless Heat Pump Project for their member utilities and their trade ally contractors, providing research, training, technical support, manufacturer promotions, and program evaluation. My name is Jonathan Moscatello. I'm a consultant, and I began working on the Northwest Ductless Heat Pump Project in 2018. The majority of my experience is in the HVAC industry, specifically with ductless heat pumps, including marketing, sales, and installation. My wife owns and operates a ductless-only contracting business that has been around since 2007, and some of the many lessons we've learned over the years will be included in this webinar content. I'll start off talking about why ductless heat pumps have become more relevant to HVAC contracting in the Northwest's colder climate areas. Then, I will talk about the installation and design practices that ensure ductless heat pumps work well to save energy and make homeowners comfortable. Much of what I will cover in this video comes from a variety of sources, including survey research with installers, energy efficiency program staff, and from experts who work on heat pump programs around the USA and Canada. You might be asking, why the emphasis on cold climates? In the Northwest's colder climate areas, adoption of ductless heat pumps lags behind the rest of the region. And in surveys conducted by the Northwest Ductless Heat Pump Project, installers in these colder areas have indicated a lower confidence in ductless heat pumps as compared to other heating equipment options. In recent years, ductless heat pump technology has improved, and now more than ever, ductless heat pumps are a viable solution for all locations in the Northwest. The current generation of modern, extended capacity heat pumps is what we're focused on here today. These heat pumps have computers inside, specifically programmed to independently control fan motors, compressors, and electronic expansion valves. They are called by a lot of different names, but utility programs call them cold climate variable capacity heat pumps. Most of the major brands have models that can produce 100% of their rated capacity down to 5 degrees Fahrenheit. They can also produce heat efficiently down to as low as -20 degrees Fahrenheit. They are nothing short of amazing. In addition to specially designed computer controls and variable capacity components, cold climate ductless heat pumps have other features that make them ideal for cold climate operations. These include enclosures that drain condensate better than earlier generations, and controls for their defrost cycle that limit defrost cycle operation only to the times that is necessary, and for only as long as necessary. Drain pan heaters, as well as optional wind baffles, can be important components that help make cold climate variable capacity heat pumps operate at peak performance. In addition to being programmed for cold climates, this new generation of heat pumps are designed to operate primarily as heating appliances. They are engineered from the ground up to produce heating comfort, and chief among these heating features is high discharge air temperature. Hot discharge air is combined with other air circulation features that are intended to make occupants more comfortable than any other technology available. One way to make ductless heat pumps viable for cold climates involves how it's applied. In a method called displacement, the existing heating system remains in place and operates only as needed. Displacement works especially well in homes with electric resistance heating, because it saves a lot of energy and improves occupant comfort. It's worth noting that displacement of other types of heating by use of a ductless heat pump works well too. The key to making displacement of electric resistance heat work is best found in step 1. This involves identifying the room or rooms in the home where occupants spend most of their time. The ductless heat pump is installed in this main living area. The ductless heat pump is sized to take over the heating requirement of the entire main living area. But for the rest of the home, the electric resistance heating stays in place. The final step involves educating the homeowner to coordinate use of their ductless heat pump with this remaining electric resistance heat. How well does this work? Homeowners love their ductless heat pump, with 91% of those surveyed saying they are very or extremely satisfied, and with savings on their heating bill of up to 50%. You may be wondering, what exactly is the definition of a cold climate? So let's get on the same page. When we speak of cold climates, we are talking about the areas in the Northwest that include eastern Oregon and Washington, and all of Idaho and Montana. For a practical working definition, areas that have an HVAC winter design temperature below 15 degrees, or which regularly experience temperatures of 5 degrees or lower, are considered cold climates. Now, let's cover a working definition of a cold climate heat pump. Utility programs and state agencies across the USA have created the list of criteria you see on the screen. A cold climate heat pump must have an HSPF rating of 10 or more. This demonstrates that the unit is purpose-built to operate efficiently. COP, or Coefficient of Performance, is another energy efficiency rating, and it shows us how much energy it takes to produce a unit of heat. For example, if a heat pump had a COP of 1, it means it would use 1 kilowatt of electricity to produce 3,214 BTUs of heat. For our cold climate heat pump definition, we want to see a COP of 1.75 at 5 degrees Fahrenheit. Since heat pumps are rated by AHRI at 47 degrees Fahrenheit, it became clear that we needed a standard that showed performance at 5 degrees Fahrenheit, which is a temperature that is more representative of a cold climate. We think a good cold climate heat pump, when operating at 5 degrees, should produce at least 80% of what it produced at 47 degrees. Finally, a condition dealing with drain pan heaters was added to the definition to prevent any manufacturer from using the drain pan heater to contribute additional heat back to their refrigerant system. The Northwest Energy Efficiency Partnerships, which is an organization similar to NEA, keeps a list of cold climate heat pump models with extended capacity and performance. This list is a great place to look up units and see how they compare. Okay, let's shift gears to the installation practices that impact cold climate ductless heat pump performance. In the last few years, the Northwest Ductless Heat Pump Project has been conducting research as well as collaborating with utility programs from all over the USA and Canada that work with cold climate variable capacity heat pumps. In sharing experiences and research findings, we learned about several common installation-related issues that impact the ability of an installed ductless heat pump to deliver electric savings and occupant comfort during the coldest temperatures. For the rest of this presentation, we will share what we have learned and offer 9 installation recommendations that help make successful installations of cold climate variable capacity heat pumps. The first recommendation we will cover is to avoid installing outdoor units on walkways or patios. The reason for this is that defrost cycle meltwater can refreeze on ground surfaces and create a dangerous slip hazard. If you cannot locate the outdoor unit to a flower bed or other similar area where the condensate refreeze will not be an issue, you may need to install a drain pan heater and piping to remove the meltwater. And you will likely need to apply thermostatically controlled heat tape to this drain pipe to allow the meltwater to be drained freely away. While an icy, frozen patio or sidewalk may not impact system energy savings or heating performance, it does make customers unhappy with their heat pump system. And unhappy homeowners are likely to tell their friends and family all about it. This is bad for homeowner electric savings in the end, and bad for heat pump business too. So be careful when locating your outdoor units. Next up, do not install outdoor units under a roof's drip line. Rain, icefall, and snow melt from roof overhangs and drip lines can refreeze on the compressor's coil surface and overwhelm the unit's defrost cycle. If possible, outdoor units should be installed outside of the roof's drip line. If this is not possible, install a drip cap or shield to keep the drip line off of the outdoor unit. It's worth noting that if an outdoor unit becomes covered with ice and the defrost cycle is unable to clear it, that system performance will suffer. This means occupants will not be comfortable because the heat pump will not be able to produce enough heat, and the system will likely be using more energy to try to compensate. The third practice is, do not install outdoor units such that they face the dominant wind direction. Some locations have a dominant wind direction, which means that at certain times of the year or during storm events, the wind will blow from a particular direction. If the outdoor unit faces into the dominant wind direction, this could cause counter rotation of the outdoor fan and ultimately lead to failure of the fan motor, fan circuit board, or both. There are 2 tips we can offer. Number 1, if an alternate installation location cannot be found, use an optional wind baffle offered by the manufacturer. Number 2, be mindful of drifting snow in addition to wind, and consider combining several of the other outdoor unit installation techniques we will describe in a few moments. The end goal with this practice and several others is to choose the outdoor installation location wisely. We need to make sure that the heat pumps we install operate reliably for years, because a system that is finicky and prone to service issues is certain to disappoint the customer. The fourth practice is, locate outdoor units where noise will not disturb occupants. Consider this: in colder climates, defrost cycle and full power operations occur frequently. During these times, systems run at higher decibels than they do at typical operations. In homes with little or no insulation or single pane windows, full power operation may bother occupants, especially if the outdoor unit is located along a bedroom wall. If you find yourself in a situation where you have no alternative but to locate the outdoor unit near a bedroom, be sure to ask the homeowner if the person that sleeps in the room is prone to waking up from noises. If they are a so-called light sleeper, you may want to go back and look for an alternative installation location. Typically, a wall adjacent a closet or bathroom is nearby, and locating the outdoor unit adjacent one of these walls may remedy the problem. The next recommendation is, install outdoor units above average snowfall depths. Outdoor units need free-flowing air at all times, and in areas with high snowfall, it is important to install outdoor units above regular snow depths. This may involve using wall brackets or an equipment stand that will raise the outdoor unit above these typical snow levels. There are a few additional tips we can recommend, and these are to remind the homeowner to regularly clear snow away from their outdoor unit and to keep an eye on the unit during extreme weather. Tip number 2 includes installing vibration absorbers when mounting the unit using wall brackets. Especially use double-ended vibration absorbers to reduce noise from transmitting through the wall. Tip number 3 is, if ground clearance allows, use brackets designed to attach to the foundation wall, as these have been found to transmit little or no noise and vibration through the structure. Here you will see several examples of wall brackets that are designed to attach to the foundation wall. This style of wall bracket has been designed to reduce or eliminate any sound or vibration being transmitted through the structure. Our next recommendation is avoid any partial kinks in the line set. Even a partially kinked line set can result in reduced capacity in low temperatures and will likely result in a system with ongoing service problems. Partially kinked line sets can be very difficult to troubleshoot because there are no error codes generated by the system. It is something to look for when a customer reports that their ductless system isn't able to make enough heat when it gets below freezing, yet you were sure you picked the right capacity system for the job. Partially kinked line sets are a surprisingly common problem, especially with larger capacity indoor units which have 1/2 inch or 5/8 inch line sets. These tubes are prone to partial kinking. Locating a partial kink requires removing the line set covers and feeling along the line set. When you feel a hot spot, this is the location of a partial kink. Typically, the solution is to replace the entire line set. Our next recommended installation practice involves ensuring the outdoor unit stays level. The outdoor units must be level both front to back and side to side and remain so for its useful life. This is important for allowing the defrost cycle to work properly and prevent ice buildup in the outdoor unit. When installing outdoor units on the ground using a pad, you must have a strong, lasting foundation for the pad itself, and this involves removing grass, topsoil, or mulch and getting down to base soil. Then, add dry cement or gravel with minus to build back up. Pack this material and level against the ground pad. Then install outdoor unit on top of that using riser blocks. When installed this way, an outdoor unit can stay level for its useful life and remain above the snowfall level requirements of the local building code. Our next recommended installation practice is to ensure insulation covers the entire line set, including the flare fittings. Manufacturers recommend that every installation have the line set completely covered with insulation, and that the insulation remain intact for the useful life of the unit. Make sure the insulation covers the flare nuts as well as the entire line set length. This ensures liquid or frost will not develop under the flare nut and cause cracks and ultimately loss of refrigerant. Full insulation coverage also retains heat and improves system efficiency. We included this installation issue in our list because incomplete coverage of insulation on line sets is a widespread issue. While it is very rare that a flare nut will crack, it is worth bringing this to your attention because no one wants to see a ductless heat pump lose its refrigerant charge. Here is a great example of the practice we recommend. Notice how the insulation extends completely over the service valves and flare fittings. The insulation is further protected with UV blocking tape. For our final recommended installation practice, we have a reminder to air seal and insulate all wall penetrations. Unsealed holes can cause internal temperature sensor errors, which can lead to serious performance issues. The effects of unsealed wall penetrations are exacerbated under low temperature conditions. Unsealed wall penetrations are a common installation oversight and point to an opportunity to create an installation checklist containing reminders for all of these necessary installation items. A thing about this common installation oversight is that it is hard to identify when it has occurred. The symptoms are not going to be immediately clear to a homeowner and might not be obvious to a service technician. This makes it hard to diagnose. I have learned that if a customer is less than excited about their ductless heat pump and complains that it can't make enough heat when it is below freezing, or finally, it feels drafty in the room where the ductless indoor unit is located, they may have an unsealed wall penetration. So there you have it, our 9 recommended ductless heat pump installation practices for cold climates. We hope you have enjoyed learning from them and that you will feel more confident installing ductless heat pumps in your customers' homes. Consider using the recommendations you learned in this video to create an installer's checklist for ductless heat pumps. An installation checklist is one of the best ways to prevent installation oversights and mistakes. In fact, it is an important tool my wife uses in her HVAC contracting company to train installers and manage the quality of every installation. You can create your own checklist by using the best practices detailed in the installer's guides created by the Northwest Ductless Heat Pump Project. These are 2 really helpful resources for installers. One guide details the practices relevant for all ductless heat pump installations, while the other details practices for cold climate installations. They can be found at the website goingductless.com. On behalf of the Northwest Ductless Heat Pump Project, I want to thank you for watching our video. For other great resources and information, check out goingductless.com and BetterBuiltNW.com. Finally, if you are an HVAC contractor, you will want to check out the free heating and cooling load calculation software available at HVACSizingTool.com. Thank you for watching.